Hi everyone, I'm gonna do a small tutorial about ECG. This is tutorial number 1 and I'm gonna just cover the basics that we need for the interpretations. So I'm a nursing student. When I was in the nursing school, ECG was one of the favorite subjects for me. So however, I have seen some people struggle with ECG, so that's why I thought maybe I'll go ahead and do a tutorial in ECG and show you guys how I interpret ECG strips. So before we go and do interpretations of the abnormal rhythms, it is very important to understand the basics, because basics is what is needed to interpret the harder rhythms. So here we go. This is a very simple representation of one complex of the heart activity. So the heart's electrical activity begins with this P wave in a normal heart. So this wave is called P wave, and it is usually followed by this QRS complex, and that is followed by the T wave. So again, this is the P wave, QRS complex, and the T wave. And there are also durations that we need to remember when we interpret ECGs. So the PR interval is is measured from the beginning of the P wave to the beginning of the QRS complex. So again, PRS is from the beginning of the P wave to the beginning of the QRS. It's shown here. And the QRS duration is measured from the beginning of the QRS complex to the end of the QRS complex. Again, from the beginning of the QRS complex to the end of the QRS complex is the duration of QRS complex. The QT interval is measured from the beginning of the QRS complex to the end of this T wave. So we need to know these waves and the complexes and the durations in order to properly interpret an ECG strip. So there are a specific times for these intervals. We'll go through that in a minute. Okay, so what are these waves? So P wave is the depolarization of the atria, and the Q wave is the depolarization of the ventricles. T wave is the repolarization of the ventricle. So one might wonder, where is the repolarization of the atria? Repolarization of the atria is hidden behind this big Q wave, and that's why we don't see that in a ECG strip. So now you see the relationship between the heart's actual electrical activity and the heart's actual activity and the ECG strip. So what do we need to know when we interpret ECG? First of all, we need to know the heart's rate and the rhythm, and then we evaluate the P waves. So in order to understand the rhythm, we also need to understand the P wave, QRS, PR interval, QT. So this is all related, but in just for the purpose of putting it into points, I have them laid down like this. So the P wave evaluation, we kind of talked about this before also. This is like the we'll talk about it. We'll talk about it in a minute. So P wave evaluation, PR interval evaluation, we somewhat talked about it before. QRS evaluation and QT evaluation. Now we will see how to do the rate measurements. There are mainly 3 methods to do the rate measurement. They are called 1500 method, 300 method, RR method, and the 6-second method. In the 1500 method, what we do is we divide the number 1500 by the number of small squares between 2 consecutive QRS complexes. This is used only when the rhythm is irregular, and this is the most accurate method to measure the heart rate. 300 method is a simpler method than 1500 method, and it is therefore less accurate. What we do here is divide the number 300 by the number of large squares between two QRS complexes. And the RR method is the quickest and the easiest method, but what we need to remember is the series of numbers that's given within the parenthesis here: 300, 1500, 100, 75, 60, and 50. What we do here is we select two QRS complexes and give these numbers for the next dark big box, the mark of the big box. It is easier when I show you, so it comes in the next slide. So I'll explain it to you when we are in the next slide. The next method is the 6-second method. So in real life, in the real clinical situations, the ECG strips is marked marked every 6 seconds. So all we have to do is count the number of QRS complexes between one 6-second strip and multiply that number by 10 to get the number of QRS complexes in a 60 seconds, so that it gives a heart rate per minute. Okay, so here we are going to using this strip, we are going to interpret the rate by using the first three methods I explained. So first we are going to count the number of big and the small boxes between these two QRS complexes. So you can see, so this is one big box. So I have to tell you something, and in usual strips, in clinical settings, there are 5 small boxes within this big box. So here you can see that this is a small box, but there are only 4 small boxes within this big box. But in usual clinical settings, there are 5 boxes. So just keep that in mind, and I'll tell you why. So you can see between these two QRS complexes, we have 1, 2, and 3 large boxes, and I have given here 15 small boxes because of the reason why I said earlier. Each large box usually have 5 boxes, so 3 multiplied by 5 is 15 boxes. I apologize that I only have 4 here, but in real clinical situation, it's 5 boxes. So and then what we do is we divide 1500 by 15, which is the number of small boxes between two QRS complexes, and the result is 100. So this is given as BPM, that is beats per minute. So according to the first method, the heart rate of this strip is 100 beats per minute, and if you remember the second method, it is 300 divided by the number of large boxes. So 300, and we have 3 large boxes, so again this also gives us this 100 beats per minute. So when I drew this ECG strip, I made it easier, but when you have to calculate the heart rate in real strips, it would be harder, but like now you see how to do it, but you can using different ECG strips, you can practice this method. So again, the most accurate method is if you use the 1500 method, and the third method is by using the series of numbers I said. So if you start here, so you isolate one QRS complex, so that's the start, and then you count the number of big boxes and give each of them a number, the number that we remembered earlier, until you see the very next QRS complex. So here it's 300, here it's 1500, and the next big box is 100. So from this method also we get the heart rate as 100 beats per minute. So as I said earlier, I drew this ECG in a way that it will be obvious to you, but in real world it's not like that. So you always come up with the best number possible. Okay, now we will talk about the durations. If you remember, I mentioned that it is important to know these durations, because sometimes if this duration is either too slow or too fast, then that could be due to an underlying problem. So it's important to know these durations. So the PR interval, the usual duration is 0.12 to 0.2 seconds. For QRS complex, 0.04 to 0.08, and QT interval is usually is between 0.36 to 0.44 seconds. So this is something that you will need to remember. Okay, so the last topic I wanna talk about with you here is the rhythm interpretation. Again, I'm not going to go into the abnormal rhythms in this tutorial. We are just touching the basics. So I'll anyway tell you how to do the interpretation and show you a normal rhythm, and then in a next tutorial I'll show you how to do the abnormal rhythms. So what do we need? We first need to know the rate. We already covered that topic, so now you know how to calculate the rate from a ECG strip. And then we looked at p-wave. So if you use this method, it is very easy to understand ECG and interpret ECG. So always have a way of reading the ECG strip. So this is my way. I'm going to show you that. So again, you start with p-wave, and then you check if is there a p-wave for every QRS complex. And then the next question is, do all p-waves look similar in shape and size? The next question, do all q-waves look similar in shape and size? And then the next one is, what are the durations of PR interval, QRS complex, and QT interval? The last question I ask is the T wave upright and round? So again, it would be nice if you can remember these questions, because this is all you need to actually understand ECG and interpret ECG rhythms. So example, we will talk about the normal sinus rhythm, that is the rhythm in a normal heart. So the heart rate is between 100 to 600, and if this is over 100, we call it tachycardia. If it is less than 60, we call it bradycardia. We'll talk about that in a different tutorial. So again, normal heart rate is 100 to 60, and a normal sinus rhythm, in a normal sinus rhythm there is a P wave for every QRS, just one P wave, not multiple, and then all P waves look very similar to each other, and all QRS complexes look very similar to each other, and these durations are within the durations that I mentioned in the previous slide. So let's have a look at the normal again. Here's the same picture I showed you. We have a P wave, and you can calculate the duration, and then we have a Q wave, so, and then we have T wave. So I first check this first complex, and then I'm moving to the next complex. We have a P wave for the QRS, just one P wave, and then we have the T wave. Next one, P wave, QRS, T wave. So I looked at three complexes here in this P wave, and then I'm going to calculate the rate. I already calculated, it's 100, so it's within 100 to 60. The rate is normal. P waves look similar to each other. QRS looked roughly similar to each other, and the durations I can check. and therefore this looks very similar to a normal sinus rhythm. Okay, so I hope you enjoyed this video. I hope it will be helpful in whatever the field you are studying, and let me know if you have any further questions. Please subscribe if you like this video, and ask any questions you want. I'll try to answer as soon as possible and as clear as possible. Thank you for watching.